So my name is Bernard Traversat. So I work at Oracle. I manage the Java SE engineering team, which is basically what you are getting out of the JDK. I've been working on Java for a number of years, so it's still something that is more than a job. It's something that we feel it's important. First, safe harbor, which means that please don't make any purchase decisions on what I'm going to say. So what I'm going to give you today is a couple of things. So the first one I was going to spend a little bit of time on upgradability. I know it's not very sexy, but that's something that I believe is going to become more and more important. The cloud, microservices, continuous development, continuous delivery, continuous deployment, continuous development, continuous delivery. So the speed of accelerations of writing services, deploying services, upgrading services is something that you guys need to take and be aware of. We'll go into 9, try to remove the fear around 9 about, I know there's been some concern, but hopefully I can give you a good sense around where we are. So far, the uptake of 9 has been very, very good. If you look at the data from 8 to 9, 9 is in fact ahead in terms of adoptions. People starting to already uptake 9. So it's a very good sign for us. Then I want to talk a little bit about modules. One of the key features that we have introduced in 9 because there is a direct relationship between module and upgradability, and so that's something hopefully I can cover. And of course all this stuff at the end really matter to the cloud and of course to microservices. So I used the word microservices once, so now I can move ahead and talk about upgradability. So it's hard, and in some way, I was trying to think about, could I find, the right image or pictures to kind of characterize upgradability? And so the best one that I found was the 3 monkey, which is nobody wants to talk about it, nobody wants to worry about it, and nobody wants to do anything about it. But at the end, all of us know that it's a very hard problem. Something that, here is a new release of Java. Oh gosh, they're gonna, those guys have breaked everything. Oh no, that means there's gonna be some work for me. I don't trust, the fact that, if I uptake a new version of Java, something is gonna break. So, in one way that's true, but also we need to acknowledge that the world is changing. Today, and in fact, over the past, few years, there's been this massive consolidations and compounding, of services into cloud environment. And we have seen, over the past few months, and you're going to see more and more, big crises. I know that there was a patch. I should have upgraded my service, and I figure out, well, there's going to be too much work, or I don't want to do it. That's okay. And then, of course, you have the big, splash where your entire services get attacked. A couple of statistics here that should give you, a fair amount of insight of the problem. Through 2020, 99% of vulnerability exploited will continue to be the one that are none, which means that people have not patched their system. In 2016, there was this report from Microsoft that showed that, over the upcoming years, we're going to see an increased number of vulnerabilities, from 5,000, whatever number it is, up to the point that, you can reach and you do the number. It's basically an average of 15 a day. So what does that mean? That, at some point in the near futures, we may have to upgrade 15 times a day. And that's a major problem for our industry. At the same time, if you're operating a large cloud environments, being able to support, end versions of the same software, And if you have multiple layers of software, it's going to be a tremendous, cost. And as we know, cloud computing at the end is going to be around utility computing, which means that, can I deploy an environment where the cost of operating, is reduced, or I can provide you, the best price performance, price per, megabytes of memory, price per CPUs. And so that's why cloud operators are going to want to have uniformity to help reduce their cost. So why do we need to upgrade? Well, security fixes. That's one, certainly a reason why we need to upgrade. Regressions. Well, there is a major bugs. We have introduced a bugs in hotspot. So of course, you need to get an upgrade to be able to fix this bug. There's a new release. Hey, new features, cool features. I want to be able to use them. More performance. Yes, from the release of the VM, you can see significant amount of performance, and you will get, improved performance. More robustness. Yes, if I get to those one, they are fixed. The VM, the libraries are more stable. Well, sometimes because the layer under you, there's a new version of the OS, new version of the software that is uptaking a new version, so you need to basically go and update. And of course, if you have multiple instances, you don't want to get multiple versions of the same release, so you want to go and have uniformity. Now, why not upgrading? Well, the first one, something is going to go wrong. I don't want to touch it, right? Next one, it's going to cost me money because I'm going to upgrade. Something is going to go wrong. My service is going to be down. My boss is going to call me. And then somebody is going to call us and say, hey, you guys, screw up. You messed up our services, right? And finally, for you guys, I know, oh, no, it's work. I have to go and basically, you took some APIs, you changed some API signatures, I have to make a change, and of course, that's something that may go wrong. Okay? Now, one thing that I wanted to do also is to kind of look at the, different technology in our industry and start to look in a little bit more detail, how those platforms, how those runtime are dealing with, compatibilities and abilities to do and upgrade services. So the first one, JavaScript. Yeah, we love it. We write a lot of JavaScript code. So, I find this very interesting statistic that basically is looking at, the 10, most, relevant sites on the internet and kind of looking at the compatibilities inside the code, on those sites. And the interesting statistic, it showed that 30% of the code right now on those sites have a bunch of ifs and else, which means that, clearly, when people have got, a new version of the browser, new version of JavaScript engine, they had to basically do ifs and else, which means that, there is not that much compatibilities. The most scary part it is if you go now to the top, what's the number? I can't read it. Sorry. The entire internet. Basically, this number go up to 64%. 64% of the JavaScript code is not compatible. So, interesting. Now let's go in Go. Well, okay, new kid in the block. Okay, it's doing relatively well, but of course it's just starting. And the interesting part it is, as some of you guys may know, we are in Go version 1. Golang version 2 is going to come, and now, oh shoot, man, decision that I made on Go 1, I need to go and basically go and change them, which means that they're going to run into significant, compatibilities and of course upgradability issues. Now, other environments, other runtime like Python, they were, you guys know, the transition between Python 2 and Python 3 was, people say, well, surgery is good, of course it's going to be painful, but at least I can start fresh in some way. But of course, there is a cost, of doing it. That, there's still, a bunch of people that are still stuck on Python 2. Because a lot of libraries, are still not working. C and C#, well, they kind of surrenders, which in some way, it's say, okay, fine. We understand, as we are moving, we will launch a bunch of APIs. We're not pretending to trying to be compatible here. We just say, hey, that's it. So let's look at on the Java side. So, Java from the beginning, we've been very concerned around compatibilities and upgradabilities. In terms of compatibilities, the Java platform is really providing, three main contracts. The first one is around binary, which means that, if you have an existing library, you should have to recompile. You can bring this class file and go and run it in the n-1 version of the JVM. We have source, meaning that, if your source is there, you should be able, to go and recompile this source to be able to get, the same level of capabilities and behaviors. And finally, there is a behavior, which is something that is sitting between, the APIs that you are using and how the runtime or hotspot is executing, these behaviors. And certainly, the intent is for us, it is to be able to maintain, the same behaviors from one release of the platform to the next release, of the platform. On the API side, something that Java did, very early on was to try to clearly separate what we call the public APIs, which are basically the API that any Java developer should be using, okay, versus the APIs that are just, internal APIs. But of course, developers, and you guys are very smart, and you say, oh man, what is under the hood here? I have this very interesting API, why don't I use it? Because I can get what I really want. Maybe in some case, you may be able to get better performance. But, this API is not part of the specification set of public APIs, which means that from one release to the next one, if we decide to kind of change the implementation, guess what? Then you get stuck now, because you're kind of depending on something and we move the ground, underneath you. The evolution of API is something that go, through a very rigorous process, which is part of the, Java community process and Java specifications, where there is a bunch of experts that sit and basically discuss, the pros and cons of how to implement, these capabilities or these behaviors on the Java platform, or, are deciding, how in fact, these APIs, which is a current API, need to evolve. But there is, a very strict, process that involves the community, and that's something that has been very useful, something that is very important, and has been, from my hand, something that was, very successful in terms of as a community driving specifications of those APIs. Now, the process that we go through, we call this compatibility review process, which is in fact something now, that is public and available on OpenJDK, where people can start to look at into the reasoning on why an API is being evolved, is something that, involve understanding the legacy, meaning that how existing APIs have been there for many years, because we don't want, when we introduce a new revisions of the API, we want to ensure that existing developers, existing applications have a path towards upgrading. We also need to understand how those APIs are going to be used today within the environment and the capability of the VM. But also we need to understand how in the futures those APIs may evolve. And in fact, if you look at the amount of time that we are spending into designing a new API, it's roughly 30-30-30, which means we're spending 30% of the time not on designing the new API, but kind of understanding how people are using those APIs. Then understanding, how we can provide these capabilities today, as well as understanding how in the futures we may decide or we may need to evolve those APIs. There is also, a fair amount of work that needs to be done around fixing security fixes, which in some case may lead us to understand that we may need to change an API because the API that was initially designed it is not secure, or because the implementations of these APIs has some significant vulnerabilities issues. And the significant trade-off between ensuring security and vulnerabilities, which is something always has to go first, because we can deliver an environment or runtime that is not secure, versus ensuring that there is an upgradability path. And we do spend a significant amount of time managing this trade-off around fixing the right way without completely breaking everything. And part of this process, I truly believe is one of the reasons that over the past 20 years, Java has remained to be one of the #1 development environment, because you guys are counting on us around ensuring compatibilities and ease of upgradability. Now moving to 9, okay? So how many of you have tried 9 yet? Raise your hand. Okay, okay. And of course, maybe the reason you guys haven't tried it is because, oh, sure, I read a lot of things about 9. We brought, a lot of things. And that's kind of the first impressions, okay? And then, of course, the second part was kind of what I will call the acknowledgement that, well, no, I don't want to talk about it. Everything is running fine on 7 or on 8. I don't want to touch 9. Well, Java 8 is fantastic. It's great. But for the people that went and start to basically take their existing 7, 8 workload and move them to 9, then and I've had a chance over the past 4 months talk to a number of customers, numbers of developers. The overall sense is that it's not too bad. Okay, yes, there is some amount of work that I need to do, but at the end, it's something that it's okay. So kind of looking into down. So the good news about 9 is that the class path didn't change, still there. You can go and kind of take your jar or whatever, put it on the class path, and everything should most likely run. Class loading has not changed. We didn't force you while we introduced in 9 a module system. We are not forcing you to convert your existing applications into a module. Yes, we understand that there are a bunch of capabilities around that are kind of private API, stuff that you shouldn't really use, but we understand that for performance reason, and there is not today alternative to those APIs. So we felt that it was the right decisions to kind of get you access to those internal APIs to get the ultimate performance, because at the end we understand with the how Java is widely deployed within the industry, that performance is something that you guys matter. So at the end, most of the existing code is there. We have spent a significant amount of time doing outreach to the main tool, the main libraries that you guys are depending on, and making sure that by the time we release 9, or by the time now that 9 is out, that a significant number of generally used libraries have a version of 9 available. The not so good news, of course, is that, well, maybe the case that you are using these obscure libraries that nobody has been maintaining, and maybe this libraries is using some internal APIs, and maybe there is some work that needs to be done here, and you may end up into a case where some more work need to be done for you to be able to uptake 9 until this libraries has been converted. If you use some components that are shared between Java SE and Java EE, you may need to adjust a bunch of arguments on the VM to enable some optional EE module that are not part of the default in your class path. A few number of APIs have been removed, and I will go in the following slide into some of those APIs. A number of APIs or tools that were in the JDK that we felt or are not widely used, have been removed. Part of our intent is to reduce our maintenance cost. And then one thing that you will see more is warning. And part of the intent, and you're going to see us doing that over the upcoming releases, it is to kind of start to give you the warning that, hey, okay, using this stuff, you should not really using it, but we give you a warning so you have the time to slowly migrate your applications. And also by the time we are kind of enforcing access to those APIs, hopefully your code would have migrated. So at the high level, if we are looking at kind of the main incompatibilities that you're going to run into with uptaking 9, yes, there is a bunch of bug fixes that may introduce some regressions. A bunch of security requirements came in, meaning that, hey, you need to ensure that on our hand, we need to ensure that the platform is secure. On your end, also, you guys need to uptake new, modern, and safe protocol. If you're using some native code, should be okay. There's not that much change in this area. A couple of change in properties, of course, deployments in the browser had some impact. Change, of course, on the garbage collection. Now G1 is becoming the default, but of course you can roll back to serial. The main area is the encapsulations of some internal APIs, and we do provide you a flag for most of those APIs, at least in 9, but we can give you the warning that, hey, you need to go and figure out how to migrate from those internal APIs. In most cases, we are providing we are providing a fair amount of documentations to help you guys move to alternative API, but there is certainly some amount of work that needs to be done here. Significant change in the overall packaging, something I will touch. And then, a few, as I say, deprecated method and functionalities that we have deprecated in 8 that now, we are removing in 9. So, as I mentioned, the number one incompatibility is most likely if your application is using a third-party library that has not been ported yet on 9, understood. So, you need to let us know, as I mentioned it, we have, a significant outreach program, so we want to know all the APIs that people are using. Also, something that we have now, and that's kind of the, the advantage that we have, it is there is such, large number of open source projects that are using Java that typically what we do is we are trying to run new versions on all those open source projects to be able to find, potential regressions in our compiler or in some case in our runtime. But it's important for us, that you let us know, which libraries, have not been ported. So we may, influence to some level and help some of those library maintainers, to speed up the uptake of 9. Encapsulation of most internal APIs. So the vast majority of internal APIs will become accessible by default, but we do provide you, an option on the VM to kind of unlock, everything. Handful of internal APIs now have very good alternative public APIs. So yes, that's some amount of work, but that's kind of work that you guys and the ecosystem should have done over the years. We've been telling people for a number of years that, hey, don't use those internal APIs. We have provided a tool in 8 as well as in 9, Jdep. It's a very useful tool for you to basically take your existing class file, run through this tool, and this tool will basically go and try to sort out and figure out which potential incompatibilities your applications may have. So it's going to give you an initial warning, as well as give you some amount of understanding of how much work may be required for you to port your applications. We introduced in 9 a new capabilities that we call the multi-release jar. So we understand that if you want to deliver one jar file, if you want to be able to support both 8 and 9, instead of having you to provide to your customer 2 separate jar files, now we let you basically combine in a single jar multiple class representations for different released of the platform. And then at runtime, the VM will figure out and understand that, hey, if you're running on an 8 VM, you're going to go grab the 8. If you're on 9, you can run on 9. Or if you're on 9 but select 8, you can go and grab the 8. And then that I say, there is like, you know, a number of command options when you are launching the VM that will basically let you, you know, unlock, you know, a number of those internal APIs. Another significant change that may impact you, it is, yes, we change a versioning string, which is, you know, going from, you know, 1.9 to 9.1.3. Okay, it's a bit painful for some of you, but, you know, hopefully, you know, the semantic of the new versioning strings, you know, provide us, you know, better abilities to express, you know, what are you getting? Is that security releases, or that's an update release, or is that a major releases? Okay, the modular runtime images. So of course, if you look at, you know, in your disk, what you are getting in terms of how the JDK is being installed, you have a completely different structure. In fact, you know, there is no more RTJAR. So if you are going and fishing classes inside RTJAR, it's not going to work very well on 9. But that's something, you know, in the first place, you know, you shouldn't have done. But, you know, we understand in some case that, you know, you went and go ahead and did it. We did remove, you know, a bunch of the Sun MISC, but, you know, what we did, and that's through kind of this, you know, early access. You know, one thing that I would want to stress here it is that, you know, we are putting early access even today of 10. You know, it's very important for you guys to go and try those early access, because you can give us significant amount of feedback in terms of, you know, if we are deprecating something and you're feeling that, you know, these capabilities or this API is very important, we may not know. And remember that the surface of the Java platform and the JDK is a lot of APIs. You know, our sense looking at active project is that, you know, some of those APIs that we have are just legacy API, but maybe not. And it's only when, you know, you uptake an early access release and have the ability to provide us feedback that we can, you know, understand, oh, shoot, you know, maybe we should keep this API. There was a bunch of, you know, different combinations, you know, from the GC around the different collectors that, you know, we're kind of trying to simplify, you know, a lot of our maintenance moving forward. You know, we announced the deprecation of CMS with G1. You know, over the past few years, you know, we have made significant, you know, investment and significant progress on G1, where now we feel that, you know, G1 is really the collectors for the vast majority of users. And certainly I will encourage you to go, if you're not yet on G1, to go and uptake G1. There is more work going on, you know, on 10, you know, 11 moving forward in terms of continuing to improve, you know, G1 and really go after the corner cases where CMS may still be better than G1. One thing to look at it is that, you know, we are putting, you know, more control around, you know, VM options that are no more supported. So it's more visible to you that if you are using a VM option that is not well supported now, either the VM will exit, or either you're going to get a warning saying that, hey, you know, this stuff is no more supported. So it's more ergonomic, something that should be easier for you to get data out of. Of course, there was, you know, couple of APIs on the add property change listeners that were basically fairly, you know, we don't expect, you know, significant use, but, you know, there may be some applications that are using those APIs. Bunch of, you know, as part of the modularization of the runtime, we have to kind of, you know, dismantle the platform and find out places where there was like, you know, absurd, you know, dependency on, you know, AWT with other components. So we removed, you know, a bunch of those, we believe, you know, non-used, you know, APIs, or, you know, fairly not relevant APIs. One significant change around the thread stop, you know, something that, you know, for a number of years, you know, it's an unsafe operations. It'd be great for us to be able to fix the VM. So thread stop should work, but that's, you know, massive amount of work and re-engineering. But at this point, I think it's better for us to be clear that, you know, we deprecate, and now this thing is going to throw in exceptions if you try to using it. We changed the GC logging. That may impact you because there is a new format. But, you know, the new we had like, different flavor of logging, within the VM. And I think what we try to do in 9 is to combine everything into one single, framework that over time will make it much easier for all of you to maintain and get, the right set of information from logging. I did mention G1, became kind of the default collectors. Certainly you can go back and use a parallel GC if you need to. It's not like we have removed it. Okay, the next big change is a 6-month release cadence. And part of the reason it is that we have to kind of acknowledge where we are and where the industry is in terms of speeding up development, delivering innovations, as quickly as we can. If we had stayed with the current model, which is roughly 3 years, 2 years and a half, JDK 10 would have been released in 2020. In the age of the cloud, that's too long, right? And so we decided, to basically move our development, engineering team from, feature-driven release, where, typically the way we were managing releases was we were kind of identifying kind of, a few main features. And then basically, the release model was that until those until those features are done, we're not going to release it. And of course, you see what happens. We try to plan as best as we can, but as we go and implement some of those very complex features, we start to realize that, oh, okay, well, maybe we need 3 more months, maybe we need 6 more months, maybe we need 1 more month, because we try to do, and we feel like it is our responsibilities to ensure that when we release the feature has to be solid. And so we decided to move into a time-based model, which is now every 6 months. And we are implementing internally this release model, and the engineering team and the OpenJDK community is fully on board. This is the time we're going to fork. And right now we are looking to fork 10, which is basically when we start to do the stabilizations of JDK 10 on December 15. Either the feature is in, if not, then basically it's going to be on JDK 11. From a management standpoint, it's much simpler because it's clear messaging to the engineering team and also for the engineers, because that's kind of telling them either the feature is ready and I can work on the final stabilizations, and if not, then I can delay. And if you know now that you don't have to wait 3 years for these features to be delivered, then that's something that is much more compelling. And for you guys, then that will enable us to deliver you innovations at a much rapid pace. Also, what we announced was that we're going to deliver a pure GPL OpenJDK release, and also we have announced at Java 1 this year that all the commercial features that we had in Oracle JDK, we're going to open source them. And so as we are progressing, then there will be no difference between the Oracle JDK and the OpenJDK. Something that will enable us to address kind of the 2 key market. If you're in the legacy, it may be great for you, then you can stay on Oracle JDK. Okay? If you want innovations, and come with us on OpenJDK, we're going to crank this stuff every 6 months, a bunch of new innovations, a bunch of new excitement. And we are certainly very excited, looking at the roadmap that we have, both in terms of significant projects like Project Valhalla, Project Panama, revamping the entire GNI system. We just announced the GGC, low latency, for once, so we can get rid about post time for Java and for JVM-based applications, and then Project Loom, which is implementing lightweight thread into the JVM. So roughly, from a high-level pictures, that means that every 6 months you will get an OpenJDK release, and then roughly every 3 years you will get the long-term releases, which is a model that is people that are using Linux are very well familiar with, and certainly that's an industry model that a lot of platforms are moving into this model. So it's simpler to explain, simpler for customers to make the choice. Either you want stability legacy, You stay on the LTS. If you want innovations, you move on the 6 months in a release cadence. So, if we look at and basically, that's data that we have kind of, mine, over the past, I would say, 5 major releases. So if you look at in clear detail, why it is hard to uptake a new version of Java. And so what we have found that basically 20% is because, yes, we have removed deprecated API. But typically what we try to do is to ensure that we give you enough notifications before we are removing those APIs. 30% are the complex cases, which is the cases where either the implementation of the spec was wrong, meaning that we have to adhere to the spec is right, but the implementation is wrong, and we do try to implement the best compatibility test suite, but some guys, we're going to miss something, or somebody will come that is doing an alternative implementation of the VM or the Java language and say that, hey, you guys are not, your implementation is not matching the specifications. And so here, of course, we may have to change the implementations. Or it can be the case that the specification is wrong. And in that case, we need to go and potentially also change the implementations. Then also there is a case that I was mentioning earlier where, there is a vulnerability here, and we need to go and make a change. Those 30% are the hard case for us because we can compromise the specifications, we can compromise security, and we can compromise correctness. So there is a fair amount of expectation that we may run, and it's not always the case from one release to the next release that we're going to run into some of those issues, but there is a case here. And finally, what we found out from talking to a large number of customers, that in 50% of the cases, the issue was all around use of internal APIs, okay? And that's where I think that, we need to kind of go back and figure out, how do we assemble, those applications? How can we better around providing kind of the right level of abstractions, where the set of public APIs are clearly exposed to developers. There is a clear contract around, hey, as a developers or as a library developers, those are the only public APIs that you should be using. If you go and start to dig inside and using internal and private API, guess what? This contract, this correctness, is not going to work. So, the best analogy that I could find it is, can we go back and look at what the hardware guys have done? So, if you go back into a data center 10 or 15 years ago, that's how it looked like. I'm sure most of you have been in these things, wire everywhere. Now, if you go now to one of the new data centers, from all the major cloud providers, then you see the difference here, right? And here there is no real magic. There's been just, very few golden rules. First one is uniformity. Every servers look the same. The cabling behind it is the same. So there is this complete uniformity. And why? Because it's easy to manage, easy to maintain, easy to understand. And then the next one is modularity, which means that I can take a piece, it's a module, I can replace it by a module. I have clean API, clean interfaces. And that's something that, if you take this analogy and look at what's happening within our software industry, then you can start to see this trend where there is this tremendous demand. And in fact, I will argue that the microservice revolutions is all around providing a better way to provide modularities between how you build services and applications. Clearly, Docker, significant innovations around providing uniform containers. You put your apps, that's a containers. Any cloud will be able to operate on this container in a uniform manner. Kubernetes, the foundations of how all those Docker containers get managed, provisions, instrumented. But the key part missing, it is, what about the app that is sitting inside this container? Okay? And that's where Java 9 and the module system is becoming so important. It's so important because module really exposed from an object-oriented programming model, what is a class that needs to be reused. Remember that in order for you to build a modularized environment, you need to get these clear separations around what are the pieces I can reuse, and I can reuse them with trust, trusting that those APIs, these behaviors, this contract that I have is there. If I look at in terms of the JDK has close to 217 packages. But how do you reuse them? How does every package that I have here can depend on another packages? Creating these dependencies, this flow of informations and contract is so important. And in 9, for once, we have introduced in the Java language, deep in the Java language, deep in the libraries and the VM, because this contract around API encapsulations is being enforced at the VM level. For once now, through the module info, you will be able to clearly expose, what are the set of packages and APIs that are public versus what set of APIs are primarily an intern APIs. That are basically saying that nobody should be using unless I give you the right to using it. So in 9, we kind of introducing, before 9, yes, we had public package, but guess what? Public package is like opening to everybody. And so the key, innovations and capabilities that we're introducing in 9 in modules is now the abilities to say that, yes, those packages are public, but by the way, they are either public to everybody, which means that at that point, any developers, can use the APIs, or those public APIs can only be used by my friend modules, or those public APIs can only be used within the module itself. And these abstractions around module is not just for us, which are implementing the platform. It's something that we are providing to any libraries developers. So when you write now your libraries using the 9 modules, you will have the same abilities to be able to protect your user from accessing internal APIs. It's important because now you can express, this clear dependency, And why is this dependency, expressing this dependency is important? Because now you have a contract that can be enforced by the VM itself. If you go back and look at the JDK 7, the internal of JDK 7, we reached to the point that this stuff was completely unmanageable in terms of dependency left and right. And guess what? Upgrading internally for us, upgrading any packages, any APIs was very complicated. So over the past 3 years that we spent working on Jigsaw and the module system, we end up into an environment that is much cleaner. And we believe by having these modularizations, use of module system, we can provide an environment that will enable you to make your services, your libraries, the platform much easier to upgrade. So, summary, the cloud clock is ticking. It's no more, don't think in terms of grading services, in terms of months, years. It's going to be seconds, minutes. To manage at scale, uniformity, cloud operators, are going to require uniformity. That's why it's so important we can upgrade. In 9, we introduced a module, which I believe it's a strong foundations to make the Java platform an environment that will make it easier for you to write services that can be upgraded. Uptake of 9 is not that scary, okay? And really my call for action, it is please uptake 9, because as we can move, the entire ecosystem on 9, a strong module encapsulations, environment, then every applications, every libraries will be much easier to upgrade. Thank you for your time. And I think we have, a few minutes for questions. Right. Thank you.
Okay, questions? Will I ever be able to use the modules of one GDK into another one? Yes. For example, if I have, I use the Oracle LTS version, but I want one feature which is already an open JDK JDK. Can I use that module?
That's a beautiful question. It is. Well, and that's a question I'm getting almost every day from a customer. Oh, I love stability, but I see you guys are working on these features, but I want this feature. So basically, I want feature and I want stability, right? So that's that's a nice thing to ask, and in some case, OpenJDK, everybody can contribute here, and in some case, the ability is to bring a new module into a legacy release will be possible, because the surface of dependency are not going to be too wide, or maybe there is no implementation that are required. So in some cases, it's going to be possible. Most likely, libraries, higher you go up, easier it's going to be. But if you go into a new feature that is doing massive surgery inside the VM, then at that point, we have, and when I use the word we, is not so much Oracle. That's one big statement that we made at Java 1. It is, we want Java to be, and OpenJDK to be more transparent in terms of bringing more people to help us advance and contribute. But we have to make decisions as an ecosystem. Do we invest in the past? Because we can do that. I can go and put engineers to go work and backport a bunch of features. Or do I move engineers into building new features that we are working on? And that's kind of the balance here.
Hi. We currently use OSGI as the Java platform module system.
No.
So is there a clear path to go to Java modules from there?
Yes. So basically, OSGI was a module system. Well, the module system was built, a few years ago, when there was no module system. And so basically, what we did with the Jigsaw module was to kind of understand the capabilities of OSGIs, but also understanding that there was one big requirement we wanted to get as a module, which is certainly expose the module system to developers, which is what was kind of the main goal of OSGI. But also we wanted to use this module system to modularize the platform itself. And in some way we are selfish here, but at the end we realized that the code base had so much dependency. You saw the graph that I showed you on JDK 7. It was completely crazy, where we had dependency left and right. And building a module system to modularize the platform versus modularize services has a different set of requirements, and that's where kind of things didn't fit very well. But certainly in the design of the Jigsaw system, the module system now that we have in 9, we work very closely with OSGI people to make sure that there is a path for be able to bring OSGI on top of Jigsaw, working sideways with Jigsaw.
So we always buy like JRebel or other tools to hard swap method level changes. So will Java provide built-in hard swap? Like we always struggle to deploy new method level changes to web containers when we recompile. Right. So
yes, so we are working on class redefinitions, or the abilities to go where you can quickly redeploy it without having to recompile and redoing things. In fact, in 9 we introduced JShell. This kind of give you now the interactivities where you can go and so we can look up more class redefinitions and be able to do hot redeployments, as well as hot patching. That's kind of, we know now the kernel, some of the kernel like Linux can do hot patching, and so what we want to do it is to bring kind of the same concept into the VM itself, where you don't have to shut down your service. You can go and redefine some classes under some constraint, of course.
Is there any change in the native API with
Yes.
J9?
Yeah. So Project Panama, go look at it. The team is working very hard with the OpenJDK community, and clearly, that's an area that we need to completely revamp. And of course, the dirty secret of J9 was we did J9 and build those API in such a way 20 years ago was to say we want to make it so hard so people should figure out that, hey, they should use Java. But of course, 20 years later, we realize that we have to accept that there is a lot of capabilities that developers should use from the native. So please look at that project Panama. It's on OpenJDK.
So Bernard, there's still more questions. There's an open space next. By chance, are you going to be able
Yeah.
to make it?
Yes, of course.
Okay, so if you have more questions, there will be open space in the next room in 25 minutes. Thanks,
you,
Bernard.
guys.